Okay, so welcome to class 3. Let me hide my controls. Okay, so today we are going to keep talking about data wrangling, and you can download the Dropbox folder if you haven't already. I think that we will hopefully get through a lot of it today, but we may have to continue on some of it next week as well. And so I do want to go over the muddiest points from last week. We didn't quite finish last week's material, but I just moved some of that over to part 4, so we don't have to go back into part 3 today. So the first one was related to fill, which I recognize that was kind of a curveball. So one of the challenges, I asked you to use the fill function. And so I provided the solution here, but it's also in the Dropbox folder for the part 3 materials now. And fill is kind of tricky because I actually was surprised that it's not something that we use in mutate. So we're going to talk a lot about mutate today. And you'll see what I mean when we start talking about that. But fill is a function all on its own that essentially fills in blanks in or empty variables in one column in one direction. So if you've ever used this function in Excel fill, it basically does the same thing. And so try running this code and seeing what it looks like. And I'll try to use this function again with more examples. It's not something that I use that often, but I think when we have that, like when in the setting where it's useful, it is very particularly useful. So some of the comments were kind of just things that are generally hard. So like finding all the problems in data files. I recognize that this class kind of uses somewhat clean data sets just because I want to teach you the tools first before we really get into some messy data. So I will try to incorporate more of those kind of very complicated, messy data sets that we can practice with. This class today, we just have the same smoking data set that's nicely cleaned up for us. But in the future, I will work on ones with problems, essentially, because I think that does take a lot of practice. There's another question about read Excel and how to select tabs. And so I think this may be stemming from kind of the term that we use. So tabs in Excel is actually called sheet. And so in part 2, there's a muddiest question that's similar to this, and I gave some examples, but I just want to point out that sheet is equivalent to what we call tab. And so sheet is what we say in Excel, and it's also the argument name in read Excel. So this tells you the number sheet or the number to tab, and it tells R to read in only that one. And so if you want to read in multiple sheets, you need to read them in multiple times with different read Excel functions. And then here, one question about here, I want to keep bringing up how to use here. We don't use it today, but in the future, I will try to incorporate it more. Just a reminder that here is relative to your project folder. And so this question is what happens because there's different data folders within each part. And so I have made a project in each part. So part 1 has its own RStudio project, part 2 has its own RStudio project, and so on. And so here only is it's relative, can only see what's in the project folder. So when you're in our part 3 project, it's going to look relative to that part 3 folder. So it's only looking in the data folder that's a subfolder of part 3. I also linked to last year's video on here. He gave another kind of example similar to what I did last week, and so you can watch that. But this is going to take some practice. It's confusing, so we'll keep working on that. This is an interesting question. So someone asked about independent versus dependent variables, like what goes on the x-axis, what goes on the y-axis, and how to think about that. And that's a good point because I didn't talk about that really at all. And I feel like people, when they are plotting, don't think about it maybe enough. Sometimes it's not a relevant question. Like for instance, you're just looking at correlation between age and BMI. Obviously, after age 18, those shouldn't really be causally related. but you do want to see if there's some sort of correlation so you can plot them against each other. If you're thinking of things in terms of a model and you have a kind of a dependent outcome versus a independent predictor, I think it's typical that the outcome goes on the y-axis and the predictor or the covariate goes on the x-axis. And I think that's just because of like kind of traditions and how we think about formulas, like when we learned algebra, whenever that was for you, y is a function of x. So y equals f of x. And so x goes on the x-axis, y goes on the y-axis, y is our outcome, x is our predictor or our covariate. But honestly, it's not that big of a deal in plotting. I don't think about it that often, probably not enough, and don't worry too much about it. I think if you're making some kind of assumptions about the model or causal pathways, you can try to put the outcome or whatever's being influenced on the y-axis, and then whatever the like influencer is or the predictor is on the x-axis. But that all kind of goes out the window too when we're looking at like box plots or other types of geometries. But that was an interesting point, so I wanted to bring that up. Another interesting comment was that they were a little unclear about how data wrangling and ggplots connect to one another, and that is a good point because I didn't really connect them last time. They were sort of living in their own worlds. This class, we are going to kind of merge them together a little bit. Usually what happens is that you have a data set, you need to do the data wrangling first in order to be able to make the plot that you want. That's usually the order of operations, I guess. And once we talk about merging and joining data next week, probably, and reshaping data, and we'll talk about what that means. We'll see how we kind of, one leads into the other, how wrangling leads into plotting. There was a question about tidy select, which I expected because tidy select is hard and confusing. And I will admit that it's confusing to me. It's kind of a new concept. It's like this new term and new package within the last few years. So I'm still kind of learning all the details. But I want to point out that tidy select is, I can think of it as like a language or a backend. It's what is used, it's the language that's used in different functions. So we saw it used with select. Today, we're going to see it be used with the function across. And next week, I think we'll probably go through some pivoting. So pivot longer, pivot wider, those also use tidy select verbs or terms or functions, however you want to think of it, and many more. So it also has to do with the fact that Tidyverse, for instance, if we think about filter or select, they use what we think of as unquoted names. You don't need the quotes around the column names. And that is nice for us. We don't have to remember that. But that is a really powerful thing and a really complicated thing when it comes to the back end. And so there's several weeks from now, we'll talk about functions and you'll see why this is hard and complicated. Essentially converting from strings to column names and back and forth. And so this tidy select also is the back end for that kind of work. So this is all way above where we've gotten so far, but it's important, and there are a lot of documentations. I provided some links if you want to read more, but slowly we'll work a little bit more with it. And this reminds me, there's been quite a few discussions in the Slack where you all have rightly so pointed out some things that I write in the homework that aren't like 100% clear. And that's just because like I'm used to kind of describing these problems in some way, but it might be unclear to a new learner. So please keep calling me out on that. Like there was a question in this homework that said like remove the columns. And I didn't think about that remove was actually a function we had learned a couple weeks ago. But I didn't mean use the remove function, if that makes sense. So yeah, just keep pointing that out because I want to learn and learn what you know and what is clear to you and not just kind of be vague about what I want. So thanks for your patience with that. There are there any questions about muddiest points at the moment? like not. There were some kind comments about what's been clear, going back to removing columns. So what I really mean there, when I say remove columns, is I mean select, but removing them using select. And so the way we typically do that is with the negative sign. It can be explicit and say select negative tumor stage. That removes the tumor stage column. And maybe I should say that selects out the tumor stage column. I don't really know a better way to say that. And then we can use what we call the tidy select language here and put a minus sign or a negative sign in front of that. So for instance, this removes all columns that contain the word day. And so that should leave all the other columns except for the ones that say day, that have day either anywhere in the column name. So that's important. And related to homework, so I think what's going to happen sometimes now is if we don't finish the class, then I might have to adapt the homework. So there's a homework in there in the part 4 today. We'll see how far we get. Probably I might have to like adapt a couple of questions if we don't cover everything. So I'll be sure to kind of send out a Slack message or an email through Sakai just when I do that, just so as everyone knows. And I don't know of a better way to deal with that. So we'll see. I guess I could email you the homework always, but we'll see how it goes. If you have ideas about that, let me know. And I wasn't planning on releasing homework solutions, but I see why they would be useful, so I think I will. Homework 1 solution, I think, is in part 1 folder. Let me see. I think I put it in there. And then part 2, I think I'm still waiting on 1, so I haven't put those up in there yet. But yeah, part 1, this is the Dropbox folder, I think. Yeah, so part 1 has solution here. And then I'll put up part 2 soon, and then part 3 once everyone turns in homework 3. And another comment, which I personally loved, was that there was a request that there's less help with the code in the homework. So up until now, yeah, I've been very kind in putting in kind of blank scaffolding code. And I had it in my head that classes 1 through 3, I'd be super easy on you and kind of give you good training wheels. But this homework, I will admit, it's going to be a lot harder. So I took away almost all of that code scaffolding. So I do recognize that that's a good way to learn, is to have to struggle a bit. But I also know it can be pretty anxiety inducing if you can't get the first part to work and you want to be able to finish your homework. So definitely utilize the Slack channel with questions and reach out to me or Colin, our TA, if you need help. I do encourage you all to work on your homework together if you are able to in this weird virtual world, just as long as you kind of do your own work, you know, in the end. But so this week definitely started early because it's going to be a bit harder. I think you're ready though, so don't get too nervous. Any questions about that? All right. Other housekeeping things. I fixed some of the readings were a little bit kind of too fast, like too forward. The old part 4 reading had something we're not talking about this week, so I moved that to part 5, added a couple more optional readings for reference. So part 4 through 6 have been updated if you want to look at the readings for that. The other thing was I put in a folder. This is my Dropbox folder. Actually, do I have it open? Yeah, so this is what the Dropbox folder looks like to you probably. And so there's a midterm project in there now. This is just a draft, but you can look at it if you want. Next week, I will put in the final version, but it's probably going to be very similar to this. But the idea is that actually, let me bring it up. Let me open part 4 project first. I didn't make that a project. And then So I opened the part 4 project first, mainly because I want this to open up in there. I don't want it to open up in who knows what project I've had previously. So this is just an RMD. It's almost identical to last year's midterm project, but I added a couple details about what functions I do want you to use. But the idea is to pick a data set that's online. There's some kind of guidelines, like it should be kind of moderately big, maybe around 2,000 rows. Make sure it has both categorical and numeric variables. Choose one with at least 4 columns or variables. So I'm not assigning this midterm project yet because I said that I would assign it next week, and it will be due February 13th, which is like a week and a half from next week. So you should have a good amount of time. I won't assign homework next week. And I want you to kind of have fun with it and explore data. The idea really is just to pick a data and then pick a research question based on kind of looking at it, and then try to answer that. And don't make it too complicated. Start looking for your data now if you feel so inclined. You have some time. I do recommend that you either meet with me or Colin to discuss what data you picked, or just message me about it in Slack or an email, because I want to kind of, we want to make sure that you didn't kind of pick a giant data set that's going to be really complicated. That's just, it's not like, I'm not going to be very particular about what you picked. It's just, we want to make sure you're not going to go in over your head and then get stressed. So just to check that. And there's some various questions that will define what you look at. And then you can look at last year's midterms. I think I showed you the link a few times. So there's some really good ones on the last year's website. But yeah, I'll talk about it a little bit again next week. And then I'll tell you when the final RMD is in there. Any preliminary midterm questions? Oh, I didn't mention that you can work on it together. I think only a couple of people took that option last time, but if you do that, there's a little bit of instructions about working together. You just have to make sure you divide your work equitably and note who worked on what, and just write some notes in the text and let me know if you plan on working together. But yeah, that's an option as well. Okay, so let me see. We are going to start in part 4. Lost my files. So you should have a part 4 folder downloaded from the Dropbox, and there should be a part 4 our project. So open that, open the part 4 RMD, and then save it before I forget to do, oops. Save it as something else if you want to edit this one. All right, lots of packages here today. We'll use most of them, I think. We're using the same smoke complete data. So I'm going to run this setup chunk, which loads all my packages and loads my data. It's the same data that we worked with last time from sheet 1, tab 1, and then your homework too. So I think I'm going to switch it up next week so we don't get too tired of this data. And so today we're going to talk about mutate, which is a way to add columns and make columns out of old columns. We're going to use case when, which is a kind of logical statement that we can use to make a continuous variable categorical, or a categorical variable more categorical if we want. And then we're going to talk about across. So I will say that these two functions are difficult to comprehend if they're totally new. It will take some practice. Please ask questions because it's hard. And then if we have time, we'll talk more about ggplots. That kind of keeps getting pushed to the end, but I promise we'll get to these kind of fun ggplots features at some point. We'll see how it goes. All right, so let me make this a little bigger. So this time we're going to talk about columns, essentially. So we last time learned how to use the select function, which selects columns, either removes them, which we use the negative sign to do that, or selects a subset. But what if we wanted to add new columns to our data? So that's where mutate comes in. This was Ted's title. I kind of agree. A confusing name, a powerful dplyr verb. It's an odd name, but I've gotten so used to it. I haven't thought about it in a while. This little visual kind of gives you the idea, is that we have these existing columns. We want to keep those in the data set. We're not subsetting or anything, but we're adding on this new column. And it might be a function of A and B, or A, or just B, and so on. And so how do we do that? Very useful function for transformation, for adding a new variable based on other variables. And so you might think of this like work you do in Excel, where you create a column and then make a formula, and a formula based on other columns in your data. And so you can do things like subtract columns, add them together, convert units, change like the text, like capitalization or something of categories in the variable, recode variables to be categorical. For instance, we saw today, entile, you can use that within a mutate statement. I think KG had showed an example of that. And then it's just very powerful in that it's very flexible. So for example, if we wanted to say, we have our smoke complete data, and then we want to create a new variable, age at death, which is the age at diagnosis plus days to death. So we're adding two columns that already existed, this one, and then we're just adding them together. Simple stuff. And that is exactly what mutate does. It creates this new column. So let's run this. And we can see at the very end, age of death is now a double numeric, and it's the sum of age at diagnosis, which is here, and days to death, which is somewhere here. And one thing I want to note is that here is an equal sign. It is not a double equal sign. It is not a assignment operator. We're not doing like a logical test, and we're not assigning an object to a name. If you can think of it more of like an argument setting, or just kind of a creation of a new column. So question, is it helpful for when you merge data sets that have different names for the same thing, like date of birth? We will talk about a way to do that next week, I think. So that's more about merging and joining. You could use mutate to rename that column in one of the data sets so that they have the same name. That is one way to deal with that, and then merge them together. But we'll talk at length about that next week. Yeah, but good question. That's all related, definitely. All right, so math is simple, like we can add them together. We can say we want to convert age at diagnosis that we found out last time was in days, and we want to convert it to years. We could divide by 365 and say now age at diagnosis is in years. So let's look at that. There it is at the bottom. Note that up here, disease was the last one, and then we had an age at death, and now disease was the last one, and then we had age at diagnosis year. That's because I'm using the pipe to manipulate and transform my data, and then I have this glimpse statement at the end, which prints out the glimpse information, but I haven't saved this work. I haven't assigned it to an object, a new data frame, or reassigned it back into the old data frame. So I'm just doing some work and then I'm glimpsing it. That's all I'm doing. Same up here. But if we wanted to save our work, this is how we would do it. Usually I suggest that you create a new data frame that's cleaned, or like smoke cleaned or smoke new, or just call it something so you know that it's been manipulated somehow, and save that using the assignment operator and smoke complete. And so I've done both of those things those operations that I did up above in the same mutate statement. So mutate age at death equals the sum age at diagnosis year equals this dividing math, and I separated it by a column. And so you can mutate multiple columns at one time. You can use, for instance, age at death. I created it here. I could use age at death here. Like I could have put this if I wanted, because I already created it. So keep that in mind. I'm not going to leave that because that's not age at diagnosis. Actually, maybe I'll add that. Age at death year would equal age at death 365. I guess technically I should note that years aren't always 365 days, right? So often, sometimes people will put 365.25 to count for leap years. That's technically more correct, but that's okay. And so if we do that, I've saved it as smoke new, and now we can glimpse smoke new, and we can see I have these 3 columns at the end. And so those are, now we've made our data frame bigger because we've added columns. And so now if I want to ggplot a geom point, so a scatter plot of age at diagnosis and age at diagnosis year, just to make sure that all makes sense, we can see, obviously it's just the same thing.
Hey, Jessica, I think your audio just cut out for us. And maybe are you unable to hear us? Nope, okay, looks like you're fixing. No. Still can't hear you.
Now?
There we go. Yes, thank you.
Oh, weird. Sorry about that. Do you know when I stopped, when I went silent? Just now, I guess. Should I repeat anything, is what I mean.
Like 20 seconds right before, we didn't let you go very long.
Good.
It was right in the middle of the graph and how
Okay.
you expected a correlation.
Thanks, everyone. Yeah, sorry, my headphones have been acting super weird today, so I'll just try these. Yeah, so I was mostly talking about this graph in that I plotted these two against each other to show you that it did what we expected, just divided it by 365, 1-to-1 correlation and all that. So that's just one way to check that what we did. And so for the next challenge, I want you to be able to play with mutate. The first thing is kind of a discussion question. I've written some code for you, and I want you to look at it and see what it does and think about why it does what it's doing and how that works. And then interpret this code with the table. And then there's some code scaffolding. It shouldn't be too difficult, but I want you to be able to just talk about it with each other and see if you can use mutate in this way. A little bit more advanced usage of mutate. So I think I will give you 10 minutes. You can come back early if you want, and we can all see how that goes. It might be too long, I'm not sure. And ping me if you need help. How many of us? 14. Let's try this. 5. Let's see, 5. Yeah, let's do 5. Okay, so it's actually 4, and Colin, you're in your own room, so you can go to it if you want. And and I will open the rooms and I'll try to give a warning. So let's come back at 4:03 and ping me if you need help. Hey, everybody, slowly coming back. Oh, let me find my, I need my solutions. Let me see. All right, I think everybody is back. Nice to see some more faces briefly before you sign off, not sign off. Okay, so I'm trying to find my solutions. I think this was this one. Yeah. So hopefully you got some of the way. If this is not enough time, let me know in the chat, or if it's too much time, let me know too, because you don't want to spend too much time on these if they're not long enough. So the idea here is that we are, let me make sure I'm recording. Yes. So the idea here is that we are using mutate to create a new variable from the vital status. So vital status is, if we look at what vital status looks like, as you all know, there's alive and there's dead, and those are character vectors. And so what we can do here, oh, 10 minutes, good, thanks, Liz. Vital status is a character, we want to turn it into a binary variable. And so what I ran here is 2 ways to make that happen. And it also kind of has this idea of what kind of variable do you want? So this made an alive and an alive 1. Alive was a logical vector. Alive 1 became a numeric vector. And so that's because here we've used this logical statement, vital status equals equals. That's a sign that it's a logical statement. Yes, no, true, false, equals alive in quotes. We need that in quotes because this is a character string, and we denote strings or characters by the quotes. And then R has this nice trick that if we do any kind of math on a Boolean or a true false logical vector, it converts it to numeric. And so 1 times that Boolean variable turns any trues to number 1s and any falses to number 0s. And so I don't think I've used table this way yet, but the janitor function table will make a nice 2x2 table or a cross table of however many categories there are. And it tells us that for false, those all became 0. For trues, those all became 1s. And I use this a lot. There are other ways to make a binary variable, but I kind of think of this as a useful shorthand. So if you are doing a logistic regression and you need your outcome to be 0s and 1s for the GLM function, which we'll talk about at some point, that's one way to create a binary variable for that.
So Jessica, what we're looking at then is that this table is telling us that there are 505 people that are dead and 647 people that are alive, correct?
Correct.
Okay.
Exactly. Yeah. And the fact that there are 0s in these terms tell us that there's nobody that had alive equals true and alive 1 equals 0. And nobody that had alive false and alive 1 equals 1. And that's exactly what we want. We want them to match up for that 1 is equivalent to true and 0 is equivalent to false. Correct. So number 2, there's no other questions. Cigarettes total. Okay, so this is sort of an odd request because why would you assume that, actually, did I even give you, yeah, multiplying cigarettes per day times negative days to birth. Like we can't assume that people are smoking since birth, obviously. But there is a variable years smoking, but it's I originally had you do that, but it's actually only available in one of the disease types. And so that was sort of odd, and it's missing a lot. Like people filled in their cigarettes per day, but they didn't fill in the years smoking. So this is an approximation, obviously not accurate, but just for educational purposes, let's do this. And so this is kind of interesting because we can just put a negative sign in front of a column name. We're not selecting out that column here. We're doing math. This is equivalent to saying -1 times, yeah, it's not a typo. And that, okay, then that is a good point. Let me show you what this variable looks like. So days to birth. Why can I see it? Oh, here it is. Days to birth is negative because this, I guess, what they did was someone enrolled in the study and then they calculated the days to birth, but from the date of enrollment, or actually probably date of diagnosis. Sorry, I'm pretty sure that's what the 0 baseline is. So it's negative. So we need to multiply by either -1. You can do it this way or like this. This actually works. I'll show you. It's sort of hard to see and looks like a typo. So it might be better to do it like this. -1 times days to birth times cigarettes per day. Same thing. So if we look at this over here, we can see cigarettes total is a large number, and it's positive, which is what we want. And number 3 was create a binary variable that denotes whether the total number of cigarettes is greater than the mean cigarettes total. So there are different ways to do this. You could calculate the mean first, save it as something, and use that number here. But you could actually, you don't even have to do that. This works. So you could say mean, what was it? Cigarettes per cigarettes total. So let's run this. Cigarettes high, which I've called meaning like higher than the mean, is this Boolean or true false statement. Is cigarettes total greater than the mean of cigarettes total? And then 1 times that. So in our function of the day presentation today with Entile, we saw something similar to this where she showed you you could filter based on Entile of cigarettes per day. So she used that to get the median. And you could use that, or you could use median, and then here I'm using mean similarly. Notice that I can't just do this, right? I can't say mean cigarettes total. That's not going to work because cigarettes total is not in our environment. It's not a name of an object in our environment. It's a column that is relative to the data frame smoke new. So if I really wanted to get out just kind of a simple way to see the mean of something is to say, I wanted the mean of smoke new $ cigarettes total. So if you remember, I mentioned at one point, the way to get out, kind of a quick way to get out the column of a data frame is with the $. And so you can do that. There's no missing data, so I don't really need to specify anything about the missing NA here, but that is one way to do it. But here I just actually say mean of the variable name in the mutate statement, and that works. And so how many people was that? Looking at the table, we see that 496 people had a cigarettes total greater than the mean, not the median. If it was median, we'd have equal numbers and 0s and 1s because half the people would be above the median value. But a little less than 43% of the people had the total number greater than the mean. Any questions about that?
I think my question is, and I've answered it myself, this is not in relation to the table of alive versus dead at all. These are 2 separate things, right?
That's true. I haven't linked those together.
Okay.
Good point. If I wanted to look at those together, I would look at, let's say, alive 1 cigarettes high is a table. I'm going to add some code. So can't spell adorn, that's why. Let's see if that works. There we go. Okay, so within janitor, at one point I want to go through all the cool things that table does. But there's a function in janitor, I'll put it here to be clear, that is called adorn title that gives me the name. Because if you notice, if we don't put that, it's blank up here. And so sometimes I forget what is that column? What are the columns? I don't know why that's not the default. But if you add this adorn title, it puts the title. And then let's do adorn ends. No, not ends, sorry, totals. No, darn, adorn, I don't even know. This is why I can't code in real time. Total adorn percentages. I don't know, I have to think about it. I don't remember how you get the row totals out. I think it's adorn totals. I don't know. I have to look at the arguments, but I wanted to put the total number here just so we could get a sense of like what proportion is. We can kind of see it. If we look at the alive and the zeros, that means people that are dead have passed. Then we have 259 that have cigarettes totals below the mean, 246 that are above the mean, and then 250 in the alive, actually, yeah, in alive, and then 397 in below the mean. So you can see the proportion is a little lower in the people that are alive. And so making a binary actually didn't really help me here because I couldn't remember which was what. So actually I would probably just say vital status here. So it makes it a little more clear. This was alive, this was dead. I rearranged the order because alphabetically alive A comes before D. And that's how you get a 2x2 table out. Oh, I do have to put, oh, thank you. Yes. Okay, so janitor has this quirk where we'll talk all about janitor later, but it has quirks where some things have to be before others. And then I can't remember how to use them. So if we want to adorn the totals for row and column, bottom and side, there's this function adorn totals, but apparently you have to put it before adorn title. I don't know why. Thanks for that. Weird are quirks. So you never get away from those. Any questions about that? I mostly wanted to show you that example because of this. You doing some kind of extreme math within mutate can be very useful, kind of like a nested math statement. And so there are many different ways we can do stuff like that. Okay, so we're gonna switch gears a tiny bit because I want to introduce factors. We haven't talked about them yet, and then we'll come back to how to really deal with factors maybe next week if we have time, probably like 2 weeks from now. But I want to talk about them because it's useful for what we're going to do with plotting, and because it's useful to know, and you'll probably come across it at some point. So we've talked about numerical data and character data, right? We've mostly focused on those. Character data can actually be made into a factor, which is a data type or a column type that represents categorical data. For the most part, character and factors can be used interchangeably, but factors have like an extra layer of information, which is what we call levels. And this levels information, or kind of an attribute, tells you, first of all, what the categories are, and then also what order they are. And that becomes important in plotting and in tables. It also becomes important in modeling. So if you've ever run linear regression with a factor or a character, you know that the reference group depends on the order of your levels. And we'll talk about that when we talk about stats stuff at some point. So for now, let's look at what happens with character vectors. So here we have simple dog, dog, cat, mouse character vector. ignoring data for now. This is like data frames. We're just talking about a vector. And so if we look at the table, then we see in alphabetical order, cat, dog, mouse. We could also have done janitor, table with a Y. We see cat, dog, mouse. There's 2 dogs, 1 cat, 1 mouse. And that's because it's alphabetical. That's the order that they're showing. But we could also make this character vector into a factor. Here we go. And supplying an argument called levels. So that's what's going on down here. We had our character vector, which again is dog, dog, cat, mouse. And we make it a factor by wrapping it in the function factor. So let's save that as an object, factor vector. I should show you the environment now has character vector, which is a character, length 4, factor vector, which is a factor, length 4. We have our smoke data from previous things. And you can see in the environment, it shows you that it's a factor with 3 levels. It's starting to tell you what the levels are. And here it's just a character vector with 4 lengths, and it just prints it out for you. So there's differences in what you see in the environment tab. And we can call back, you can say, what are the levels of factor vector? And it just prints them out. It doesn't tell us how many of each. It just specifically says, these are the levels. This is the order. But what if you wanted the order to be dog, cat, mouse? You can actually specify the levels inside the factor function. So you'd have your character vector, comma, levels equals dog, cat, mouse. And that's saying, if we look at this, run that. Now the levels of factor 2 are dog, cat, mouse. And so let's look at table again. Actually, let's just do table. I don't like regular table. Janitor table with a Y. A factor vector, cat, dog, mouse was the order. Factor vector 2, dog, cat, mouse. Let me run them together. So we can see the order switch. Nothing else about the data switch, still the same counts and everything, just the order. And so this ordering, like I said, is really the main reason you use factors. But there are other useful things about it, because there's a whole package called the 4cats, which manipulates and collapses in groups and reorders factors. There's a lot of factor manipulation. So having all those tools is really powerful. So I would argue that's another reason to use factors. If you, I don't know, if you start plotting in ggplot with factors, you'll see why order matters. And we'll have an example, but the more you use it, the more kind of the problems you'll see with plotting. So that's why I want to bring it up now before we get too deep in ggplot. So the mini challenge is just kind of think to yourself. Let's say we wanted to change the order of factor vector to be mouse, cat, dog. Verify that you did it correctly by calling table. So the key here is the levels, right? Up here, we specified that we wanted our levels to be dog, cat, mouse. And so in order to change the order, you would move these around. So I'm just gonna copy and paste, because why not? And so we want mouse to be in front. I do want to show you actually. So table now, mouse, cat, dog, great. What happens if I kind of got confused and tried to say mice? Let's look at that. Now mice went away. So that is another thing to be very careful of. You need to actually say what your levels are, exactly matching the character strings, right? So this used to say mouse, and now factor vector is missing mouse. Wherever mouse was, it didn't recognize that as real data. It changed the levels to be mice, cat, dog, and then it changed our vector, put that as missing. So be very careful. Everyone makes this mistake and then gets really confused at some point. So that's one thing, like one error you should be, if you end up with a mysterious error, check your levels of your factor. Make sure you specified them correctly. Okay, so that was the side about what a factor is. Factor, very, very brief and basic information about factors. You might want to use that in mutate. So up here, I was just working with character vector, factor vector, and use the factor function on one vector. You can do that in mutate. So for example, smoke complete has a variable gender, which I don't know if that means self-reported gender, but it's only male and female is specified, and it's a character vector, 2 categories here. And so when we use factor on that, and we don't specify the levels, it's going to automatically order it in alphabetical order. So let's look at what happens here. We've set gender to be equal to factor gender. And notice that I'm using the exact same variable name. And what that means is I'm overwriting that column. Gender used to be a character vector, but I've redefined it as a factor, and I've reassigned that name to be the factor. So let's look at wherever it is here. We can see that it's factor. It looks exactly the same as it did before, except now it says factor. FCT stands for factor. And if I were to say, save this as something like smoke, let's just redo it as smoke complete. It's just smoke complete factor. So I've saved it as a new data frame, and now I want to see what the levels are of gender. And so that's telling me female, male is the levels, that's the order. And if I were to look at the table, so smoke complete factor, then pipe, then table of gender, we see female is first, male is second, and we can see the counts, 68% male. I will say that I prefer table with a Y from the janitor package because it is what we say, like how we say pipeable. Any function that takes the first argument a data frame is most functions that take the argument a data frame as the first argument is going to work with a pipe. And so that's why I like that, because I can do 2 stats, vital status, 2 variables and get a 2x2 table and so on. So that's just my habit of using table, though table without a Y is also a thing. And this is what I was commenting on. What we're doing here is reassignment. I've reassigned gender into be a factor gender. We're taking the previous value of our variable, doing something to it, making a factor, then reassigning the variable gender to our fixed set of values, our fixed columns. And so, like I said, you can specify the levels. So you might do that if you wanted to rearrange the levels. So you could have factor gender levels, and then you could do male, female, or female, male, either way. So actually, that didn't really do anything because I think it was female first, right? Yeah. But you could switch that up if you wanted. Yeah, now it's male first. So if I were running a regression and this was one of my covariates and I wanted male to be the reference value, I would probably do this to make sure that my odds ratio or whatever I'm looking at is the reference value is male. Because there's more of them in this data set, I guess. I don't know, but you could pick. So that's one way to do that. And so let's use that information, make sure there's no questions. So let's use that information now for ggplot. And we, yeah, I guess we haven't had a break. Let me see when, technically no breaks. When's our next challenge? Not for a bit. Maybe after ggplot, we'll have another break if we have a chance. So for ggplot, we haven't talked about box plots yet, really, I don't think. So one new geometry is called box plot, and it's called geom box plot. I think, yeah. And so what you use box plots for, you've probably seen them before, is comparing a distribution of quantitative variables among categories. And so we have our vital status. We made an alive variable that's a binary variable. So now we essentially have 3 variables denoting the exact same thing, whether someone is alive or dead at the end of the study. The vital status itself is a character vector, but we don't really care about the order of those categories at the moment, so we can use that as is in our box plot. I made the smoke new just of all the work that we did up above, just to make sure we're all on the same page. And so here I have a ggplot function of the data smoke new. I specify my data, then I specify the aesthetic, and I'm mapping X to vital status, which is just a character vector for now, and then a cigarettes total as the Y. This is our quantitative, I can't spell, quantitative variable. This is our categorical variable. And then we put geom box plot as our geometry. Add them all together. And so we see, sort of hard to see because of this outlier up here, but slightly higher median total cigarettes in this group, dead group versus alive group. So the box plot gives us the median and interquartile range and basically the spread with some points where we see the outliers. And the main differences from the scatter plot that we've done earlier, that we created earlier, as the geometry. So the geom now is box plot. We could have used geom point. Actually, let me just see what that looks like. That is an option, but it looks, when you have a categorical variable and a continuous variable and you try to make a scatter plot, it's going to look like this because you only have categories on your x-axis, right? So not usually something we do. Something like a box plot or a violin plot or even a jitter plot, which we'll get to at some point. I think that's actually a function of the week one, jitter, geom jitter. Those are more appropriate when you have categorical on one of your axes. You could actually have, so going back to kind of what you put on the x-axis, what you put on the y-axis, you could switch this. I say it's typical to do the categories on the x-axis here, but I've seen it both ways. It actually looks better here because we have a wide versus smaller height, wide format plot, I'd say, so you can kind of see the differences a little better. So that's an option. So I'll just do this for now, just keep it consistent. And so we haven't talked a lot about fill yet. So color we used for scatter plots here. When we have box plots, color, you can set color, but color is the outside lines. Fill is going to be the color inside the box plot C. So we set fill to be vital status here. So again, we have both the exact same x-axis is the same as the color. So obviously that's representing the same information, not entirely necessary, but it does make it a little more visually striking. And so that's one way to set colors here with the fill aesthetic. And so going back to factors, now is the point where, what if we decided we wanted to switch these? I suppose you could recode your variables so that they say something different and force it to be in that order. But the easier way is to just make it a factor and specify the levels. So here I want to specify that alive is after dead, so dead and alive. And so I've said smoke new, and I've mutated vital status. I've reassigned it as a factor with these levels and done the same plot. So let's look at that. And now we can see they've switched. The x-axis values have switched. And so maybe that is what you prefer for your plot. And so box plots are pretty simple, used quite often. Another ggplot aspect I want to talk about, I meant to talk about this last week, but ran out of time, so I moved it over here, is faceting. And that can be a very powerful way to show data when you have a lot of different categories, maybe that you think will change your plots significantly. So for example, say you're plotting gene expression, and you have a batch effect and you want to plot the average gene expression across batches. You could do that with a box plot and have like multiple categories on the bottom and have like 2 different categories that you split it by, because that is one way to do it. But I think faceting is a little clearer, as we'll see. So again, ggplot smoke new, same plot, same x-axis, same y, same fill, but this time we're going to use facet wrap around the categorical variable disease. And so you have to put this kind of odd wrapper, that's var's disease. That's just by nature of the function. So whatever this is, so this is disease is the name of the categorical column, whereas the other stuff are functions. Vars is a function saying use that variable. Facet wrap is the function that says facet our plot by that function. And so I'm using the word facet because that's what ggplot says. That may not mean anything to you, but this is what it does. It makes subplots based on the disease. So we have BLCA on top, CESC, LUSC are our 3 categories. And it's taken all of those groups and separated them out. And so now we can see that certain diseases have different patterns of cigarettes total. And that is a very useful thing. I facet plots all the time. There are arguments to facet wrap that are useful. For instance, if you only wanted to have, like, let's say 2 columns. So I encourage you to read the help. There's one argument end call and end row, so a number of rows and columns. So let me just add that just so you see. Let's say I want to limit it to 2 columns. What does that look like? Now we have forced it to only have 2 columns and then wrapped it around to get the 3rd one in the 2nd row. So you can customize it different ways like that. You can also change, you can see that actually that's forcing everything to have the same scale, like the same y-axis limits and scale, like so everything lines up. And I think generally that's a good idea, but there may be cases where you want to change that. So that's where scales comes in. And so there are many personalizations for that. One note is don't try to do this with a numeric variable. That's not going to work. You're not going to have like 50 different facets based on however many 50 different unique values, or 500, depending what it is. Like I said, look at the help function. The other faceting function, I actually tend to use facet grid more often than facet wrap, because sometimes I have 2 variables that I want to facet by, and I'll show you what that means. So this is the exact same plot. I don't know why this is adding color. It's not right. And this is rows equals, so facet grid instead of facet wrap, then rows equals var's disease, calls equals var's cigarettes high. So it has 2 arguments, rows and columns. I'll do the help function for this. Facet grid, rows, calls. You actually only need to specify 1. You could force it just to have columns based on 1 variable. But I'm going to do 2 variables just to show you. So now we have cigarettes high, if you remember, is a 1 when the cigarette total is higher than the mean cigarette total, and a 0 if it is lower. So this isn't a very good plot, actually. Yeah, it'd be better if I could see, if I could like stretch it. I can zoom in. Maybe I'll do that. Sometimes you'll see this as this one outlier is making everything else shrink down. So that's something to be aware of, is what happens when you have outliers. There are ways around it. I could limit the x-axis or the y-axis and kind of zoom in if I wanted, but I just want to show you, just for illustration, what facet grid does. And so we have our cigarettes high on the the columns, and then disease on the rows. We see our 3 diseases. And so this you can do with like a scatter plot and see how your patterns change based on 2 different variables. You can kind of compare subgroups of your data, which is really helpful. And so things like this are, I would say, number 1 reason, maybe number 2 reason to use ggplot over base R. This kind of thing in base R plot is really hard to do, but so easy in ggplot. So things like this, where you just kind of split up your data and show the data in different ways, it's really easy to do in ggplot, and I appreciate that. All right, so let's have our little break now, and you can do this mini challenge, basically fill in facet wrap, and then let's take a 5-minute break and come back at 4:44. I'm gonna write that down in the chat before I forget. I'll see you in a minute.
Thank you.
Yes, yeah, good question. So I think, let me know if this is what you're asking. So request to go over this part again. So facet grid, so we have 2 ways to facet. Facet wrap. Let me look at the facet wrap again. Facet wrap, you can see the first argument is facets. I haven't named it because that's just the first argument. And so you can always just put that in order, and R knows what to do. Oh, maybe this is what you're talking about, ncall. So facet wrap takes an argument that's VARS disease. And let me remove this again, just to show you what that looks like. So it's taken VARS disease and made a faceting by that variable, but there's only 3 variables. And so R tries to be smart and like guess how many columns you might want. I don't know if ncall has a default. I don't think it does. I think it's just based on some smart algorithm. And so I'm going to add this argument, ncall equals 2. And that is saying I want it to force my facet wrap to only have 2 columns. And so it's done the exact same thing. It's made 3 facets. And then it has wrapped them so that it has 2 columns and 2 rows. If I had said ncall equals 1, then we now only have 1 column of plots, and it has 3 rows because there's 3 objects. What else is in this data set? So actually, let's look at skim. So we have other categorical variables in here, and I think tumor stage has a lot, 17. What has 6? Okay, race. Let's try race. So let's look at what happens when we facet on race without ncall. Okay, so like I said, I think R has tried to force your plot to not be too squished. So by default, it wraps them in order, like 1, 2, 3, 4, 5, 6, like you're reading left to right. These are the different races that are in that data set. And then if I don't like how that looks, I want ncall to be 2. If I specify that, now I forced it to only have 2 columns, and it wraps it down to fit the number of facets, and it's now a 3x2 data. So facet wrap usually you use with just one grouping variable. The other one is facet grid. Usually you do that with 2 variables, although you don't need to. So if I had removed the column specification, we can see I've said rows is disease, and which means I want 1 column, 3 rows of the categorical variable disease. But I had specified calls. So calls is based on the cigarettes high 0, 1 variable. And so that's saying the column facet is the cigarettes high variable, and the row facet is the disease variable. Hopefully that answered your question. let me fill this in. So this should be var's gender facet wrap. Oh, wait, what did I do? Then I thought this was easy. Oh, Wylam. Oh, I don't know why that was there. That was a trick that I didn't mean to give you. Thank you. So I don't know where that came from. There was that Wylam thing that apparently was left over from something. Sorry about that. I got confused. Facet wrap then wraps by gender. YLim usually we use to limit our limits of our YLim, like our y-axis, sorry. But in this case, because we have this categorical grouping, it complained it did not like that. All right, thanks everybody. Okay, so that was sort of a detour into ggplot world. We'll come back to it. What time is it? I think we have time to do some hard mutate things. So next up, we're going to talk about different ways to use mutate. So we did show how we would use mutate to make a factor. Now let's talk more about other useful ways to use mutate. One might be is if we have missing data and we want, we want to replace it with something. So here we have our smoke new data, and then I want to mutate and create a new column where I've replaced all the NAs of days to last follow-up with 0. So if we look back at, let's glimpse smoke new, see what we're working with. We have a days to last follow-up variable here, right? It's numeric, it's a double, it has missing values, NA. So let's say that if we wanted to specify that actually those missing values should be 0, I want to replace them with 0. So I'm going to create a new column. I'm calling it days to last follow-up 2 because the column name was already long and I wasn't feeling very creative. So that's what it's called. And I just want to show you what happens. So I've created a new variable. Actually, let me glimpse it first before I do fancy things. You can see now that it's here at the end. We can look at days to last follow-up and days to last follow-up 2. It looks like it's doing what we thought it would do. We can see NAs have become 0. One way to check that a little more cleanly that I wrote here is I say smoke new, and then let's select the columns that contain the word follow-up, because see how I named this follow-up 2, this is follow-up, and look at the head, the first few lines of that. This is just sort of like a trick to myself that I do when I'm doing some mutating and I want to just check that I'm doing what makes sense. And so now they're lined up. I could have, instead of said head, I could have done view, and that pops up this data frame, and I could like scroll through it, just kind of check all the NAs are now 0. So it's doing exactly what I want. So just sort of gut check, making sure things work out. So I don't want to leave view in my RMD. You may have noticed if you have a view function in your markdown and then you knit it, every time you knit it, you're going to get these pop-up windows of all your data, which is fine, but I don't like that. So I try to avoid using view only like interactively, not in my markdown if I'm planning on knitting it later. But just a reminder, I haven't changed my smoke new data frame. I'm just kind of doing this selecting so I can see it better, and then head so I can see it better. I haven't changed that data because I haven't used this part of the code. I haven't said smoke new assign to this smoke new with mutate and smoke new, etc. So there's this kind of difference between saving it as something and just manipulating data to look at it. All right, so this is our first hard thing. In the last hour, we're going to hopefully cover 2 complicated things. The first being case when. If you've used R, you may have used this already, or you may have used another function called if else. I'm not going to go over that, but this is a related function that is useful. So if you haven't had a programming class, if statements are probably foreign to you, but I think they're close enough to like normal concepts that I think that should be easy to understand once you practice with it. So the idea of an if-else statement is it's telling R, or telling the program language what to do if a statement is true, otherwise or else, then what do you do? So like, let's say if vital status is alive, then set outcome to 1 or something like that. So if this, do that. And then the else part of it is saying other cases. So if vital status is alive, do this. If else, then it's meaning the vital status is dead, then do something else. And case when is an even more extreme version of that, because it's if this, else this, else this, else this, else this. So you can do many, many chained if else statements. And I'll show you what I mean by that. It's essentially looking for cases. That's why it's called case when. It's looking for many options in your statement. So an example to make this more clear. So let's say we want to turn our cigarettes per day variable, which is a numeric continuous variable, into a categorical variable with 2 categories or 2 values. So we want to split it up, 0 to 6 cigarettes per day, not including 6, so less than 6, and greater than or equal to 6 cigarettes per day. So how would we do that? We actually did see a way to do that, which is using my kind of trick and turning a logical statement into math, into a 0-1 variable, which would mean we'd say cigarettes per day greater than or equal to 6 is a 1. Otherwise, if it's less than 6, then it's a 0. But here we're going to use case when to do something different. And we're actually not going to use a 0-1. We're going to use these category names. So that's a little bit more flexible. So case when follows this basic pattern where we have a tilde. You'll see in R, this tilde is used a lot for a lot of different things. Usually it's related to a function. We'll talk about, and formulas, sorry, not function, formula. We'll talk about different ways this is used. But in this situation, we have this little tilde in the middle. And on the left, we have our condition, our like if statement. And on the right, we have the name of the category that we want to call it. So the left side is where we specify how we define the category. And the right side is where we specify the category name as a character string. So in this example, we use case when inside of mutate. Can you do multiple conditions with case when? Yes. Yes. Like cigarettes per day is less than 6 and vital status equal to alive. Yes. And that is the great power of case when. I don't think I did any examples. I don't remember. I don't think I've done examples where you combine them, but that is definitely an option. And I will be sure to do more examples like that. So starting out simple, like super simple, because we only have 2 categories and we're only using 1 variable name, 1 cigarettes per day name. This is like as simple as it gets, but case when can accommodate many different complex iterations of this. So I want to show you the syntax is a little confusing and will take some practice to get used to. So you need to say first smoke new and pipe. So we're taking the data frame and then we're mutating. So within mutate, so this is the mutate parentheses and parentheses. The new name, maybe I'll annotate this. New variable name is cigarettes category. So this is what I'm creating. And category equals case when. So that's where you put the case when after the equal sign in the mutate statement. And that's because we're saying this cigarettes category variable I'm defining as this sort of categorical variable that we're making with case when. So when you're doing homework or other code, pay close attention to how you order this. It's important. So case when then gets its own open and close parentheses. That's here. I've put them, separated them out so you can see the kind of like insides here of the case when function. And again, this is what I was talking about with the tilde. So the left-hand side says cigarettes per day less than 6, tilde, this is the name of our category. And then we have a comma. So that's our first category. Then we have cigarettes per day greater than or equal to 6. And we're calling that 6 plus. And so separated by comma, I forget the comma all the time, and then I get an error and I have to look to see where I missed the comma. So don't forget your commas, and then don't forget your end parentheses. And then, so I'm chaining this together. I've mutated and created the cigarettes per category. I actually didn't need to do another mutate statement. As I showed you, you can put that inside the same one, but I did just kind of for clarity. Then I mutated it to make it a factor. So that's actually not necessary. Maybe let's just get rid of that for now. I'll show you what happens. So let's run this. Here we have our category name, and then the number of values in that category. So only 52 people smoked more than 6 or greater cigarettes per day, whereas 1,100 smoked less than that. If I had kept in that factor line, it doesn't noticeably look different. If I had, let's replace this with glimpse so you can see it. Let's scroll down. We can see now we've added a column that it has 2 levels, a factor. These are all the values 0 to 5 or 6 plus. So the question about, can we put other like predicates in here, other logical statements? Yes, you could have said cigarettes less than 6 and vital status equals alive, for example. The other thing to note about case when that will become obvious at some point once you work with it more is that it's performing these steps in order. So it's saying if cigarettes are less than 6, then call it that. Otherwise, or else, if cigarettes are greater than 6, then call it that. And if I had another one, then it would say if cigarettes per day are greater than 10, then call it that. So you can think of it as in your mind that R is going in and labeling your data, doing one step at a time. So if we had a value of 2, it would see that first line and say, okay, that's less than 6. Let's call it 0 to 5. And then if it looks down the row and it says, oh, this is greater than 6, then turn it into 6 plus. Then later, if I had greater than 8, it would have, then nothing would really be left actually, because it had already changed everything into 6 plus. And I'll talk more about like this ordering of operations once we have more rows. It will become more clear. Any questions so far about case when? Okay. I think, yeah, let's do this. Let's have a quick breakout room session, same breakout rooms. And so now here I want you to make 3 categories. So you'll have to fill in this part. You'll have 0 to 2, 2 to 6, 6 plus. So you'll need to remember how to make logical statements. Hint, you'll have to use an and statement to do this. The intuitive way actually that you might think of doesn't actually work, sadly. So you have to do the and I'll talk about what I mean. So let's do 5-ish, let's do 5 minutes, 5:07, come back. If hopefully you have enough time to at least talk about it. And we'll come back in a bit at 5:07.
It's not how math works, Jessica. You're on mute in this if you're talking to us.
Sorry, I'm just talking to myself over here. Yes, oh, and I did answer you, Joseph, your comment about how math doesn't work. So what I was saying is the intuitive way that I would do this, I kind of hesitate to show you this because it's not going to work, but I'll let you know. Cigarettes per day, less than 6, right? That's what we would think. 2 less than cigarettes per day, less than 6. That doesn't work. Actually, let's see what happens. No, it's unexpected. So what we have to do is chain these together with an and statement. So I'll say 2 cigarettes less than, or cigarettes greater than 2 and cigarettes less than 6. Get rid of this. And you could write this either way. I think you could say cigarettes on the left hand and whatever. You can have this all rearranged however you want, as long as it's true when it's between 2 and 6 and false when it's not. So let's run this. Correct. So we should see that this middle category is using an and statement to chain those 2 tests essentially together. And we've made it a factor. The ordering makes sense because it's alphabetical order essentially, which is alphabetic and numeric. So we see 0 to 2, 2 to 6, and 6 plus.
Jessica, is it necessary to offset those? I did it without the parenthetical statements and still got the same thing. Doesn't matter.
Correct. It doesn't. I do it just kind of for readability, but this does work. Should work. That's what you mean. Yeah. I mean, yeah, you can do it either way. I don't know why that works, actually. I think of it as like, math order of operations kind of thing. But it does work to take out the parentheses. Yeah. And I think that's all I wanted to say about that. Did anyone else have any comments about that? Yeah. So you can see how you might want to make categorical variables. In our function of the week, we saw n-tiles, which creates categories based on percentiles. And then there was a mention of the function cut, and cut actually will do this for you. But case when I find just to be a little more readable and more flexible, as we'll use it for other examples. And so another example I want to show you is with actually character vectors. Usually it's used with numerical vectors because for character vectors, we tend to use the factor functions. But I do want to show you that this is one way to do that. So let's again remember what tumor stage is in this data. It's a categorical essentially variable with many options. Stage 1, stage 1A, 1B, stage 2, stage 2A, 2B, 3, blah, blah, blah. There's also a not reported. So many categories. So let's say we wanted to kind of group these together somehow, collapse the categories into 3 stages, not 3 stages, but 3 categories. So let's say stage 1, stage 2, and everything else. You can just do whatever iteration of this you want, but let's just make 3 categories. So there's some important things about this example. I'll show you the example first and then talk about it. So what I've done here is I said smoke new and then mutate, and then the name of the column I'm making, so stage category. I've categorized my stage. And I use case when, and then I have multiple statements. And so just now we saw that we used an and statement. This actually, I could have done this differently. I could have said when tumor stage equals stage I, or when tumor stage equals stage IA, or, and when I say or, I mean using the or, the pipe or statement, or tumor stage equals IB. But a slightly easier way, I think, just for readability's sake, is to just use commas, because what this is saying, if tumor stage equals stage I, call it I. Otherwise, if tumor stage equals stage 1A, call it I. If tumor stage equals 1B, call it I. And then if else,
tumor stage equals stage 2, call it 2, blah, 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 call these all 2. And then a shortcut to doing blah, blah, blah equals other for all the other options is to just say true equals other. So that's saying if, else, everything else, call other. You have to be careful with this when you have missing data. We don't have any missing data here. So just be aware, just pay attention when you have missing data. You might need to say if tumor stage is NA, or if N is NA tumor stage, then make it NA, like keep your missing variable the same. But otherwise, this is a really handy way of just like collapsing everything else. So those are my 2 points. You could have made a more complicated or statement, or just use commas the way I have. And then the true statement, knowing that that is going to take all the other possible values and make those set equal to other. So let's run this. I have down here a 2 by 2, or like a cross table of tumor stage and stage category. So tumor stage is I, 2, 1, 2 others, I, other, and then, or not tumor stage, stage category. This is again the issue with not having this title thing. There we go. So stage category is these three options. Tumor stage is all of these before. And you can see not reported became other. 99 of the rows had a not reported tumor stage. These 3 became stage category I. These 3 became stage category II, and the rest down here, stage 3, stage 3A, stage 3B, stage 4, all became other. So that's doing exactly what we had hoped it to do. All right, any questions about that? Cool. Okay, the next, so case when, very powerful, kind of hard to wrap your head around. I get that, it takes practice. The homework has case when practice. It does not have a cross practice. I want to use that a couple more times next class. So we're going to briefly introduce this today, and then use it again next time. And then I guess you won't have homework next time, but at some point we'll have practice with the cross, at least during challenges and stuff. So if moving on, switching gears, case when is a way to create a new variable out of an old variable. It's a very specific way to do that, using essentially chained if-else statements. A cross is totally different. A cross is a way to mutate multiple columns at once. So you can imagine that you may want to perform the same operation to several columns. So for an example, in our smoke complete, we have all of these days to birth, days to death, days to last follow-up columns. And let's say we wanted to make those in terms of years. And so I would do the exact same thing to all of them. We would say mutate years to death equals days to death divided by 365. Create another column, years to birth equals days to birth divided by 365. Years to last follow-up equals days to last follow-up divided by 365. That's fine. It's kind of cumbersome. It's not too bad. But if you had to do that with 25 different columns, you can imagine that's a lot of typing, and there has to be a better way, and there is a better way. That's like the whole point of computing, is making things easier for us. So that's what a cross does. And so in this example, the syntax is essentially data frame, pipe, mutate, across, and then you have your column names, and then your functions, or your functions. So columns, names, and then functions. Let me make sure that's the name of the argument, because I don't remember. Dot call, sorry. So that's the syntax. It's somewhat hard for me to remember that everything goes inside a cross. So just be careful with that. I always, for some reason, want to put the function outside of a cross, but Don't make that mistake. Everything goes in across. So it's like a nested across inside mutate situation, right? So looking at this example, we're saying smoke complete and then mutate across multiple columns, the exact same function. In the multiple columns part, we do have to chain together with the C, but we don't put them in quotes. We just use the bare column names, days to death, days to birth, days to last follow-up. So that if I wanted to name that argument, I could. So that's columns. And then the functions, I'm just going to apply one function to that. This is very specific syntax. So I mentioned earlier, this tilde shows up a lot in R, and we're going to see it again and again. It sometimes is unexpected, but in this case, kind of makes sense because we're defining a function. And so when we define a function, we put a tilde in front of it. We use this special name for the X variable, like what's being put into that function, and it's .x. And then our function is divided by 365. We can use built-in functions, and I'll show you examples of that, but I wanted to show a kind of custom function first. So let's look at what happens. So we've mutated across 3 columns. We've done the same function, which is dividing it by 365. So look at days to death. Previously, is this days to death? No. Let's see what it used to look like first. Let's do, before we do anything, let's run the whole thing. Okay, so the first one, days to death here, you can see 371, 136, etc. So that's almost a little bit over a year. And then down here is the second glimpse result. And we see days to death is now 1.016. So what happened here? It looks like we can see we have not added any columns. So that is one nuance about across, is that we are not adding columns. We're not renaming columns. We're doing this action in place. We're reassigning days to death as days to death divided by 365. Same with days to birth, days to last follow-up. Those 3 columns just changed in place. So that's one, I would say, kind of annoying thing about across, is that there's no kind of like default way to just change the names. So one way to get around that is, I have an example down here, is to use the rename function. So that's what's happening here. So this is the exact same code as above, using across to change those 3 columns into that column name, that column value divided by 365. Same code, but I've added, and then rename years to death. So rename days to death as years to death. Rename days to birth as years to birth. Rename is a new function for us, but what it really is just a wrapper on mutate. So if you think of it as a mutate, it makes it more clear why the left-hand side is your new column. You're creating, you're essentially creating a new column, years to death, setting it equal to days to death, and getting rid of days to death. So rename is, like I said, a wrapper around mutate, but it does what the name of the function says, rename. Let's just look at this. So now, if we look at the place where days to death was, now we have years to death is in years specifically. So I started out by saying it's cumbersome to type all this stuff, and then I went and typed the rename. I admit this is not the most efficient way to do this. There is another way, but I don't want to get into that yet because I don't want to throw too much at you. Sadly, the syntax to do like a parallel thing with rename is slightly different than this, and it's confusing. So bear with me, we'll get there eventually. Right now, let's focus on across and how to use that. Later, we'll talk about like automated renaming. But this is kind of a way around it, a little more typing, unfortunately. Any question? Okay, good questions. What if you wanted to use a function inside across? Like if you want to standardize columns by dividing by their means, how would you do that syntax? Yes, exactly like that. So Let me copy that. Yeah, some either way. So like if you wanted to, let me just do this. So let's say I wanted to divide by their mean, like that. Let's see what happens. I don't want to rename this. So we can see this should work. Oh, except I don't. So what I did was I divided by its mean, but days to death has missing values, right? So I made the rookie mistake that everyone makes all the time. So I need to set this remove equals true. And where to go? Days to death. Let's skim. Actually, let's subtract off the mean because, and let's divide by the standard error. This is going to be complicated and look ugly looking, but just so it's easier to see, SD of point X, NA.RM equals true. So this should be standardizing. Did I get enough? No, this should be standardizing those variables. So let's look at that. Days to death, mean is essentially 0. You'll notice this in R. Sometimes if you subtract off the mean and divide by the standard deviation, it changes it a little bit. So negative 3.35 e to the negative 17 is numerically close enough to 0. So we have mean 0, 0, 0, standard deviation 1. Yeah, great question. So that is how you would kind of make a more complicated function. And when we talk about making custom functions later, I think probably in 2 to 3 weeks, we'll cover that. You'll see there's a little bit easier way to do this. I would actually have made, well, first of all, I think there's a standardized function in R, so I might have used that. Second of all, I would make my function outside of this code and then call the name of that function. That is probably the way I would do it rather than, this is hard to read, as we can imagine dealing with all these parentheses and stuff. But that is, you essentially have no limits with your point X here. You could do whatever you want. Any other questions? All right. Yeah, don't forget to take out your missing data. So let's talk about the function, I mean, not the function, but the columns part. So what I did was I specified, if we look at my code, specified the days to death, days to birth, days to last follow-up, right? I specified the 3 columns I wanted to happen or to use, and I put a C around it to make a column concatenate of those 3 column names. But it actually uses the tidy select syntax language. So the same way that we used tidy select inside select. So for example, let's say I wanted to say starts with days, select the columns that starts with days. That gives me exactly those 3 columns. So I'm going to use this starts with days inside of across. It works the same way. So I didn't actually have to write out the column names. So now we're getting even more efficient. We're reducing our typing, which is always nice. So let's run this. It should do the exact same thing. I've mutated across all the columns that start with days, and I've divided it by 365. Then, because I haven't shown you a better way to do this, I've renamed those 3 columns, and then I'm glimpsing it just to get a look. And so it did exactly the same thing. We have like this 1.016 from our years to death column. So this can be nice if you have like 45 columns that start with days. That's one way to shorten your typing, make things more automated. So I'll say that across is take some getting used to. Across didn't always exist. There used to be other functions called mutate if and mutate at and mutate all, mutate where maybe. So actually, if you look, I think if you, anything like more than 2 years ago probably uses all those and it doesn't use a cross. So if you're searching for like, how do I change multiple columns at once in Tidyverse, you're going to see a combination of results. So I would focus on learning a cross because those old functions are going to go away at some point. It's harder, a cross I think is harder to use than those old functions, but it kind of unites the language across all the different, as you'll see, we can use a cross in mutate, and we can use it in another function summarize, which we'll do next week. So just keep looking at examples. So those examples up above, I use this .fns equals tilde .x, right? I've created my own function .x divided by 365, which says divide everything by 365. But if there's already a function that does what you want to do, you just use the name of that function, and that's even more simple. So let's say two new things in this example. The first is this tidy select function language that says, I'm going to mutate across all columns that are numeric. And the way I find all the numeric columns is using this where is numeric. We use where around a function that returns true, false. Is numeric returns true if a column is numeric, false if the column is not. So that's what's happening here. We're saying all the numeric columns, testing it with this is numeric function. You can actually, this is a function, you can read the help. It's very simple. Is numeric is a general test of an object being interpretable as numbers. Where, I wonder if, yeah, where is in a tidy select package, select variables with the function. So it's a selection helper that selects variables with a function that returns true. So tidy select has very specific language. This is kind of one of the weird ones where you need this where around your is numeric. So that's telling us what columns to mutate. The second thing is what function. So let me make this more specific. Calls, yeah. Calls is where numeric. Functions is just the function replace NA. So we saw replace NA up above where I used it inside one mutate statement. I think I don't remember which one, one of the like days to something. I replaced all my missing values with 0. And so I'm going to do the same thing here. The quirk about using a built-in function is that if there's an argument that you want to use, you want to put it after the name of the function. So replace NA, comma, oops, no, replace NA, comma, then I put the arguments of replace NA. So let's run this just to see what happens. It's running this and then it's glimpsing. So all the numeric values, actually, let me glimpse it before and after. And the whole chunk. So before, let's look for one that has NAs. So days to last follow-up has NAs, years smoked has NAs. So after we mutate all of the numeric values, days to last follow-up now has zeros where there were NAs. Years smoked now has zeros. Year of death, and obviously no one's year of death is 0, so you wouldn't really want to do this, but I have replaced all my NAs with zeros. So that is very useful. I could do the same thing where, let's say, where is character, replace with missing. Although I don't know, do any of these have missing? I don't actually be able to, I don't know how much missingness there is in our character vectors. But in theory, if we had missing data in our character vectors and we wanted to replace it all with the word missing, that would be a possibility. Let's see if anything shows up. No, that's all right. But that would be the way you would do it if that was a useful thing to you. So this where is character, you could say like, where is double, where is numeric, where is factor, that's useful. those tend to be the common ways of using the where, I'd say. And remember that when you have a built-in function, you would put it in the function name, but then you put the arguments after that function, after the comma. So if it had multiple arguments, you would put multiple arguments after that. Any more questions? Another useful way of using this is to just convert everything to a factor. So here I am taking my data and then mutating across all columns that are characters and turning them into a factor. So if we glimpse that, we now see we have factor, factor, double, factor, factor. They're all of our column types have been changed into a factor. So that's an easy way to just make everything a factor if you need to. So the mini challenge, just kind of think about on your own. So we have our Palmer penguins data, bringing back for a little bit. So what if we wanted to convert all the variables in the Palmer penguins data that end with mm to cm? So millimeters to centimeters, dividing by 10, similar to what we just did. Does anyone remember the tidy select function where we would highlight all of these? I'll put it in the chat if you remember. Yes, ends with. So that is what we would put here. Ends with mm. And then we just want to divide by 10, kind of like what we did dividing by 365. That part isn't that hard. And so now previously this was like, well, let me show you. True. Oops. So previously we had 39.1, 18.7. Now we have 3.91, 1.87. And then of course we probably want to rename MMs to be CMs if you want to be especially rigorous, I guess. So I think, like I said, I don't think the homework had any across examples, but I'm going to do more examples later and we'll have practice with that next week when we talk about summarize, and we'll use it in similar ways. Okay, so like half an hour left. I think we can talk a little bit about ggplot. Switching back, this is kind of like fun stuff to end with. Once we got through some data cleaning, not really related to what we just did, but switching gears again. And so we have ggplot. We've shown how to make a couple different geometries, scatter plot, box plot. Another geometry that we might want is a violin plot, which is essentially kind of like we saw geom smooth. Mary presented that last week. Geom smooth, or not, sorry, geom density. I'm mixing them all up. Geom density, but it's a geom density mirrored on an image on itself. You'll see when it looks like a violin, I guess. And so we're going to actually layer geom violin on top of geom box plot. And so that's one nice thing about ggplot is you can just stack a bunch of stuff on top of each other. And so let's run this just so you can see it before I talk about it. So we can see there's a box plot and then there's these violin plots. So it's like a density, but mirrored. So we can see that there is a tail. We could see that both from the box plot and from the violin plot. But you do get a sense that like there's a good amount of data down here. You don't really see that so much in the box plot. So you get a little bit more information. You could kind of see a little bit better. Is this normally distributed or whatever information you want. One thing that I want to note is that I fixed the alpha level and the width for geom violin. These are not, this is essentially an aesthetic, but I haven't mapped it to a variable. It's like a setting or a parameter. And an alpha is how dark, how opaque it is. And so by setting it at 0.5, that's like 50% opacity. And so you can see it's a little lighter and filled than the box plot. And then I set width to be 0.5 because otherwise it would be exactly as wide as the box plot. So you get a little bit of more definition in seeing what it looks like. I could change this to like 0.6 0.7575 or something, and you can see it gets bigger. Yeah. Oh, and that reminds me, so in the homework, again, with my not being very clear in my instructions, I said save your ggplot as my plot. And to me, I should have made this more clear, means save it as an object named my plot or whatever I said. Here I'm saving our ggplot as an hour box plot. And you can actually see in the environment that it's a type GG, which just means like ggplot. And it's actually a list. It's like giving you all the parameters and the characteristics, so all the information of your ggplot is in there. So I save it because if I want to add a layer, like let's say I want to change the theme, it's easy to do because I have called it something. So I can just keep adding stuff to that named ggplot. So that's what I meant in the homework when I said save as. Sorry, that wasn't really that clear because save means lots of things, as we found out. So layers, boxplot, ggplot, boxplot, violin plot. Easy to add things that make sense to be layered on top of each other. So once we are able to layer multiple things, another useful change we might want to make are regarding scales. And scales is a general term that means like the scale of your x-axis or your y-axis. So for instance, you may want to transform your y-axis to the log scale, or if you have certain tick values, like you can see, this one has 0, 5, 10, 15, 20. You might change the tick values to be 0, 2, 4, 6, etc. You could do that with scales. You could also change the tick values of the categorical values. There are ways to format values, such as like adding dollars or percents. And then also to change values to particular colors. So for instance, I want here LUSC is blue, but let's say I want to make it purple or something, then we could do that. So all of these kind of changes have to do with scales. And so up here, the default, we've set our fill to be disease. Oh, sorry, I forgot to mention, when you're layering geometries, notice that the box plot and the violin plot have the same fill. And that's because we specified it in the aesthetic. I could have overridden that. Here, let's just make them all black or gray, I suppose. And so now we can see that we have a different fill color because I've told it to change it. But by default, it inherits the aesthetic AES that we've given it. But right now it just kind of uses the default colors that are in ggplot. So we can change all of that. We can say, for example, this is our plot from above. Oh no, this is a new plot. So this is a scatter plot. Let's look at that. So this is a scatter plot of age at diagnosis, cigarettes smoked per day. And we can see the axes, tick marks on the x-axis are 10,000, 15,000, 20,000, etc. One way to change those breaks or those tick marks is using the scale x continuous. So whenever you want to change the scale of one of the axes, you would use scale x or scale y, and then whether it's discrete or continuous, you specify in the name of the function. So you can actually look that up in the help. And we see that there's breaks is one of the arguments. You can specify the limits. You can specify the labels of the breaks. So you can really customize a lot of this stuff. And so let's run our plot, but I'm going to say our plot plus did I run that? Scale x continuous breaks. Did I actually run this? No, I highlighted. Yeah, so now scale x continuous breaks is at these 3 points. So sometimes you might do this if you have like certain numbers are important to you and you want to show those on your plot. That's one way to do it. And then a mini challenge is, how would you modify the y-axis then to have the following breaks? So our plot is this here, and we want the breaks to be, what did I say, 2, 4, 6, 8, 10, which actually means get rid of the 0, which I wouldn't really recommend. And I made this too easy because I gave you a hint that that it's actually scale Y continuous. But all you have to do is specify breaks equals this. And so now we have this kind of odd break situation that only shows those numbers, which is not actually that informative, but it is possible. And so, like I said, scales, you change the tick marks, but often you are probably plotting not just numeric values, but things that have certain units like dollars or percents I use a lot. And so you could say, I'm going to make this labels dollar. So the way we do that is use, again, the same function, scale Y continuous. So I'm changing the Y axis, which is a continuous value, but I'm using the labels argument this time. And there's a package, scales, which has a lot of these functions about labeling. Label dollar is one, label date, label scientific p-value is really useful. And then label percent. So let's look at what happens here. As we expected, probably there's dollar signs now in front of our numbers. So instead of like converting your data to have dollar signs, you actually just convert the plot image to have dollar signs there. So I would say scales, I don't use the axis scales all that often, but I do use the scales for color and fill and like size or any other of the aesthetic mappings that we have that are more about the visual aspect of the plot. So let's say we have our colors are mapped to a categorical value. In this case, it was disease, right? We had the 3 diseases and we got our default colors. So we're going back to the box plot, or are we? No, we're still scatter plot. So the default colors are red for BLCA, green for CSC, blue for LUSC. But I can specify I want those colors to be different. I can also specify one of the other arguments is name. And so this is all in the function scale color manual, which is a hard name to remember. I always forget the manual part. I guess that just means you're manually changing it. There's scale fill manual, scale size manual, etc. You do need, like if you're trying to change the colors, you need this values argument. I just added the name just to show you that you can also change the name of your legend at the same time. So let's run this. And so we have disease category has, this used to just say disease, like the name of your column. But now I made it just look a little nicer. And then you can see the color mapping has changed to the colors I specified. And R has a whole set of named colors, which you can see in this document. Like besides the usual red, blue, orange, pink, there's all kinds of colors. You could also use like the different ways to make colors with numeric values. And there's a lot of other ways to do this, which I'll show a couple more examples. And I think it's a little more common rather than specifying the exact colors. Like maybe you do this if you are trying to fit a theme of, I don't know, your university has specific colors that it wants you to use maybe. This is one way to do that. But people tend to just use what we call color palettes. And so you can use these color palettes for fill and for color. There's some built-in color palettes in ggplot, but there are packages that have kind of silly or very useful palettes, depending on your opinion. For example, there's the Wes Anderson package, which has Wes Anderson palette themes based on like the movies, which is amusing. So for example, the Isle of Dogs palette looks like this. And so if I want to use one of these built-in palettes, I would then use scale color manual, but I would set the values to the palette. So this, rather than saying like light green, lime green, whatever, I just use this palette name. And then it automatically picks 3 of those colors from that palette. I'd say for the box plot, so this is for color. I mentioned that you can do the same thing for fill. So let's try that. This is our box plot that we called our box plot. And then we're adding scale fill manual in the same way. And so we have those same 3 colors, but it's a little easier to see here, mapped to our 3 disease groups, but as box plots. So I don't want to, this is just to show you that there are other palette names. You could pick one of the other ones, let's say Darjeeling, and use that. But the key here is it's what you put for the values, and R is specifying those color values. That one's more bright. The other, I'd say that people often use gradients if you have something that is like from low to high. Your color is like a numeric value. So for example, let's say we want the same kind of scatter plot, but we now want a color based on year of birth, which is a numeric value. It could be categorical, I guess, if it's limited numbers, but I'll just show you. So here, year of birth goes from 1920 to 1980. And the later years are the brighter blue, and the darker colors correspond to the earlier years. And that's because we've set this scale color gradient, which is a function that has an argument low and high, low being the color for the low values and high being the blue, or high blue being the color for the blue values. Yeah, so this is, you might actually pick like a different, not black, but you can kind of see, you can pick more bright colors, and it becomes a little more obvious, I think, to see what's going on here. So we can see that trend that older people are older at age of diagnosis. That makes sense. And then the last thing I want to mention is the built-in palettes, which I tend to use a lot. So right now, so far, we've seen scale color manual and then scale color gradient. But there are some built-in ones using the Viridis palettes, which are quite aesthetically pleasing and also colorblind friendly. So that's useful for visualizing and like not including the sort of red-green denotation. So let's see. This one is scale color Viridis. The weird thing about these functions is that you have to specify D for discrete or C for continuous. I don't know why they did that, or why they couldn't have just made one function, but that's how they did it. I always forget about that, but you do have to make sure to say, like, if you tried to use C here, it would complain and said discrete value supplied to a continuous scale. And that's because your color was a discrete categorical variable. So just keep that in mind. But I think I like these palettes. They're pretty. There's actually different options. So there's like 1, 2, 3, 4, 5 different palettes within the Viridis palettes. And this is the A option, which is magma. So it's just different. Okay, so we talked about Wes Anderson. That was silly, but there are so many silly ones. There's this package that has many palettes from many packages. You can look at the website and it has like the full long list. Actually, you can see all the, maybe I'll just do this. You can see all the packages and all the palettes. So I encourage you, if you are into making your plots look really nice, you can find some fun ones. There's a Taylor Swift one based on her albums. There's Tableau. I actually like the Tableau one. I use that one a lot. I just find those colors appealing. So check it out. And that's kind of part of the fun part of ggplot, is doing more fun stuff with it. And we did miraculously finish what I thought we wanted to finish this week. So that's great. So that means the homework should be doable. It's in the folder. Let me know if anything's not clear, please. Hopefully not. If you want more practice with both of these topics, there's the R Bootcamp interactive like lesson thing that Ted and I created, and you can do some of these chapters, and there's some reading. Don't forget to fill out the survey. I forgot to mention, did I mention this? That I put a Sakai gradebook item for your attendance. But again, you can fill out these surveys whenever you want. So if it says like you've only filled out 2 of them, and that's fine. If you fill it out later, that's totally fine. But I'm just I wanted to keep track for you so you could see what you've already filled out. Hopefully you all can see that in Sakai. And thanks for your questions, and let me know if you have any more questions later. Have a good evening. See y'all later.
Thank you.
Thank you.